Alright, class. Cosine x over 1 minus sine x equals 1 plus sine x over cosine x. Recognize if you try to work on the right side, the reason why I wouldn't multiply by the conjugate, you would get the difference of squares. So the point of multiplying by the conjugate, especially in this problem, I decided to work on the left side, is so that I can get the difference of squares. And the reason I want the difference of squares is so I can use the Pythagorean identities. So I'm going to go ahead and multiply this side by writing this here. You chose the side with the hole. Alright, so I'm not gonna distribute here. I'm just gonna keep it as is. Here I'm gonna go ahead and multiply these. One plus sine x, 1 minus sine x. So if I multiply those, what do I get? When you simplify that, what do you get? What do I do next? Partner B, tell partner A. 1 minus sine squared x. Brittany, what does 1 minus sine squared x become? Why is that? You're just subtracting sine squared there. So I have 1 plus sine x over cosine x. Now here, I was tempted to do 1 plus sine x times quantity 1 minus sine x, difference of squares. I was tempted to do that so I can cancel them. But I look on this side and I recognize that cosine still needs to be in the denominator, so I wanted to change it by Pythagorean. Remember, cosine squared x is what cost? There's 2 of them, yes? And then lastly, I can just do what? I shouldn't have done the equal sign over here. 1 plus sine x over cosine x, you don't need the parentheses, is equal to 1 plus sine x over cosine x. And we have verified using our identities.